The broadcast is now starting. All attendees are in listen-only mode.
Hi everyone, and welcome to today's webinar on delivering value through automated drilling control. My name is Kenza. I'm the Regional Sales Manager for EMEA, and I'm very happy today to be presenting this webinar with Sven-Inga Odegaard, who is the eDrilling COO. Sven-Inga has been working with the drilling control and information systems for the last 25 years. Not to mention the last 10 with AI, machine learning, predictive analytics, and digital twin technologies, which we will talk about in this webinar. Just a little housekeeping before we get started. This webinar will take about 30 minutes or less, including the Q&A session. And at any time, if you have any questions, you can type them on the question box you will find on the GoToWebinar panel, and we will answer them at the end of this session. So the objective of this webinar is to show how an automated drilling control solution, and you will also hear me just calling it ADC, helps improve decisions, consistency, speed, and most importantly, safety. But before, let me take you through this roadmap so you can understand how the technology has been evolving and also understand what is the background behind the automated drilling control solution. As you can see, we are talking about accurate dynamic transit downhole models, real-time optimization, but also we are talking about artificial intelligence and predictive analytics. And these are the additional tools which not only help in the decision-making process during planning and the operations, but also are the key enablers towards automated drilling control solution for robotic drilling and self-drilling rigs in the future. Back to the base of this solution, the key enablers for automation is accurate modeling with AI. The answer is then model-based reasoning. To have a realistic representation, all the models need to be updated with an input from other models in real time. This means that the thermohydraulics are updated in the torque and drag and vice versa. Drilling and tripping is a dynamic process, so therefore you also need dynamic models to represent the real well. Dynamic effects from fluid, cuttings and influx movement, pipe movement, temperature effects, and so on need to be accurate. And here you can see a list of some of the effects that the models are handling in real time. This is multi-phase flow including fluids, cuttings and influx, static and dynamic density, pressure and flow, temperature, rheology of different fluid, frictional pressure loss, cuttings load and transporting the annulus, bit gain, kick development and kick tolerance. And for the torque and drag model, weight on bit from hook load and vice versa, torque on bit from surface torque or vice versa, axial and rotational friction factors, bit depth corrections due to string elasticity, buoyancy, pump rate and pressure, well depth, rotational speed and block speed, drag forces, and nozzle pumps. And these dynamic models are today used across the different phases of well construction. In planning and design to improve safety, margins, and planning cycle time. They are also used in preparation phase for training and to perform trial runs on upcoming wells, but also to acquire skills and experience. And of course, during operation, to do real-time optimization and have to make good decisions. These dynamic accurate models are again also one of the components for the ADC solution, which is designed for an integration with the rig's drilling control system and to help keeping the operational parameters according to well limits. For those who are wondering about these products, they are today used in 13 countries across the world, and this is also a technology that has been used, developed, and continuously made better over the last 25 years. So just as a side note, we have had over 5,000 users of our digital twin technology. And also this year, we are celebrating 10 years of successful operations with our closed loop automation solution for MPD operations. So back to the technology. I mentioned AI and predictive analytics are key enablers towards ADC. So let me now explain how they provide value to the real-time operations. For real-time operations, we make a digital twin of the well, which is continuously updated by the real-time data from the rig. And the principle is then to enforce continuous optimization by using AI and machine learning to provide diagnostic messages when any risk is detected, to do predictive analytics and forecasting to be aware of any upcoming risks, but also to do what-if analysis, which is then important in order to optimize the operation. For example, when it comes to finding the optimal running speed. Here, the end goal is to provide added value to the customer through recommendations to ensure optimum well performance, a safe operation, and of course, help in the decision process. Let me now show you an example of how it is possible to do optimization in well construction planning using the same tools. What we have done here is to have an automatic pickup of the input data from the company system like PDM. Then numerous what-if simulations are automatically run with different flows, running speed, etc., to then select the fastest simulation within a safe window. So basically select the optimal parameters for the operation. And it's all done via microservices. The goal here is, in this particular example, is to reduce the planning time and get the optimal plan with the possibility to replan quickly based on the actual ongoing operation. So over to you, Sven Inge, to tell us more about the automated drilling control solution.
Thank you, Kamsa. I will try. During well execution, optimization focuses on efficiency to ensure the right combination of parameters like weight on bit, flow, and RPM is obtained to maximum rate of penetration, ROP, while operating within the envelope of the surface and subsurface equipment, and of course the well condition. You will get consistency in the operation from having an automated function performing the operation in a safe and consistent manner each time. An example is that connections will be the same regardless of operation crew. And how does this work? The digital twin driven by real-time data is the basis for this. In real time, an optimal tripping speed will be calculated based on the actual status of the well from the digital twin and from the predictive analytics ahead. During drilling, an optimization routine will be initiated on certain intervals that is configurable, which will start multiple what-ifs using the real-time updated twin and select the optimal based on the diagnostic system to ensure you are within your envelope related to well control, pour and frac limits, volume control, and hole cleaning. The one with fastest ROP without any diagnostics will then be used as optimal flow, optimal ROP, and optimal RPM for the next given interval. If abnormality occurs detected by the diagnostic system, then ADC will send a stop or abort command that will bring the operation to a safe condition using best practice procedures. ADC has four main modules besides the safeguards in the safe well response module. These are a trip module that also covers running with liner or screen, trip out module, connection module, and a drilling module. You will get both consistency and optimization in the different modules. Some more details about the different modules. First, we have trip-in module, including casing and liner running. That gives you optimal speed and max acceleration with the surge effects and the volume to fill the string during a trip-in. A trip-out module that handles optimal speed and acceleration due to swapping effects. A connection module with the following: pump startup, optimal flow related to that, jailbreak, RPM and flow, and of course pipe movement, both surge and swap. And a drilling optimization module with multiple what's if initiated to find optimal hole cleaning and optimal pressure in the well. Main focus here will be ESD and ECD. This will of course then get optimal flow, optimal RPM, and optimal movement or ROP. And as mentioned before, safety safeguards are covered by the independent safe well response module that includes first action, immediate start, using the existing diagnostic module for volume, pressure, weight, and frictions and cutting monitoring. Best recommended solution is based on best practice procedures, and this can be company-based. In the list here, some of the existing diagnostic include pore hole cleaning, forward-looking kick, impending stuck pipe, loss and kick detection, etc. are mentioned.
All right, thank you, Sven Inga. We will go ahead and take some time for question now. Just a reminder, please be sure to type your questions into the question box you will find in your control panel.
Okay, we have a question here. How can ADC be implemented with an existing drilling control system?
Okay, I can answer this one. So basically, the ADC or the automated drilling control can send safe well response or optimal flow or optimal RPM and an optimal ROP to the integration layer provided by the drilling control system providers. And this could be, for example, Novos or Deal or any other system.
Okay. Yeah.
Yeah. Okay. The next question. Yes, it says you mentioned 10 years with closed loop NPD control using your models. Can you outline some on this?
Yes, I will do. Sure. Since 2008, our models have been embedded with an MPD provider control system, giving real-time choke pressure setting that handles all transient operation, including connection, back pressure pump on and off, and so on. It's used in drilling, tripping, liner running, and cementing. The offline version is also used for planning prior to operation.
Okay, I can take the next question. What is needed from the client side to implement ADC? Well, to implement ADC, we need to do some integration work with the drilling control system provider. And this is all based on the OPC-UA interface with the standard signal list.
Yes, we have another one here. In your opinion, what are the critical factors that can make the technology work? Oh, I can take that. It's data quality, and of course humans. System and technology are fully ready for this now. Another one here. What is the possible time saving that can ADC provide?
Maybe I can answer this one. So actually, you will get a consistent operation with optimization. So it is maybe difficult to set a number on this, but everyone can see that by having an automated drilling control solution, the main achievement is an increase of safety by reducing the risks ahead, but also efficiency by having consistency in the operation and the possibility to optimize the speed.
Okay, I see we have a question here. Can ADC be run over local cloud, or does it need to connect to servers outside of the country? It's a good question. It can be run on a local cloud, but normally ADC will be run maybe on premises hardware on the rig. But everything is designed to be in a local cloud or a wide area cloud, or of course on local machines. It's also a question here: which wells or regions did you use to test calibrate the software? This has been tested a lot in different areas of the world. The models are physics-based, so input parameters related to formation, temperature gradients, and so on is required to run the models, and these are normal or these are available in well planning. So we don't need to do something with the software other than configure it in different operations, and it's been verified in many operations.
Yeah, I guess this is also linked to the next question I see. How does your RP optimization react to formation changes, and how the formation properties implemented, or is it based on delta performance?
Yeah, good question. We have an embedded ROP model in the torque and drag model that takes into account the bit you are using, the formation you're drilling in, and so on. And this is published information that we can share upon request. Another one: how frequently does the optimization run? What is the execution speed? Good question. How often that is configurable? It can be either based on the next 100 meters or feet that you're drilling, the section you are drilling, and so on. So this is configurable. And then is the execution speed. The execution speed, so everything is optimized to run on several cores of computer hardware. So the speed is around 100 times real time doing these optimization routines.
Yeah, I see there's another person who asked about, I guess, the same question: how frequent optimized drilling parameters are provided while drilling?
There's one control loop going always, which then gives commands every second related to this, related to optimize the speed and so on. And then you have this optimization that you can set up for an area or section ahead.
And then, yes, a question about, again, the cloud solution. Is it possible to use cloud services for your calculations? Yes, we can, as mentioned before, we can use cloud solution, but we can also use local service.
Yeah. So we are using it for many customers. We're using Amazon and Azure clouds already. It can also be run with Kubernetes solution, so that everything is where you can automatically spin up hundreds of simulations. So that's how we do it.
Basically, different solutions are possible based on the customer's infrastructure as well. I see a very good question here. Is there a risk of receiving false drilling flags on hazards?
Yes, sure. That's of course possible, but we have a data quality module that quality checks data that's coming into the system to avoid this, to take away whale points and so on. to reduce the risk of having this. But bad quality data in will of course be be important to avoid.
Yeah, I guess that's linked to the next question as well of how are you handling bad input that could be received from the rig sensors?
Yeah, it's the same.
Yeah.
We have a data quality module that quality check that the data are within expected limits. The dynamic models, who will create this? Is it something a user can create easily? Yes, it's the user can create different simulation easily. In an offline version, you can run multiple what ifs yourself if you like to. But in ADC, all this is automated. So this spins off a lot of dynamic models automatically.
I guess, yeah, we still have another question about the input data. Or maybe we can take this one. Is it required to have any specific hardware to be delivered as part of the ADC? And does ADC require any outside support while drilling?
Yeah, hardware. This can be run on any hardware. It's based on a Microsoft server or any virtual server. But it's important on ADC that you do a risk assessment related to where to have your hardware, related to where you have your drilling control system, so that this is a safe system.
Okay, there is a question about the cutting transport model. Could you speak to your cutting transport model?
Yeah. We have a cuttings slip module in the software, which means that you will calculate the percentage of cuttings related to the ROP that you have, the fluid that's lifting it, and so on. And if you stop circulating, the cuttings will slip. So this is the cuttings transport model we have, and this is of course updated in real time.
The next question is about the plans forward. So any plans of extending the modules beyond drilling, for example, to well intervention? So I believe this is not in our plan at the moment, but nothing is closed. So
yeah, that's we have a product roadmap that we follow quite strictly, and we talk to our customers and related to build the product roadmap ahead. So this is a customer-driven roadmap.
Yeah, that's really based on the market needs.
Yeah.
A question about the importing the BHA. So the question is it easy to import the BHA from EDM or via WITML? So maybe you can tell a bit more about how we have done it with one of our customers.
Yeah, this is been done with WITML. We can just, if it's available on a WITML server, we can pick it up automatically. If we are supposed to, if we are set up to import it from EDM, then we just get the job number, the job ID in EDM, and then the system automatically goes to EDM and collects this, and of course quality check it before we run it in the system.
Yeah, so this is currently something that we have been doing for some of our customers, and nothing that we require any development. Okay, next one. Is it possible to feed real-time caliper logs into the simulation for calculation purposes? For example, cement volumes or cutting accumulation?
Of course, you can feed this in, and you can visualize it. It's not used in real time for these calculations at the moment.
How do you consider the cutting diameter density of offset wells in the model for calculating the slip velocity?
Yes, I can answer on that. this is something that you get from neighbor wells, of course, and then you give that as an input to the system. So that's an input, both the cuttings diameter and the cuttings density prior to start.
All right. It looks like we have covered all of your questions. So let's then wrap up. And to summarize, so today we have the possibility to provide automated drilling control solution to help improve decisions, consistency, speed, and safety. And to achieve this, it's important, one, to understand the well behavior, and this is provided by the real-time digital twin based on advanced modeling capabilities. Number two is to have tools which can detect upcoming problems, but also to optimize the operation. We mentioned predictive analytics, forecasting, and what-if simulations. And three is safe well response and first actions based on best recommended solution for optimal flow, ROP, and rotation speed. So this concludes our today's webinar. Thank you, everyone. We really appreciate you being here. And if you have any further questions, please don't hesitate to send me an email. We will also be sending the link to this recorded session to all the attendees. So thanks again, and we will see you next time.